Hi everyone, this is Thomas Curry, and I'll be going over the description of SIMOC. And SIMOC is basically a scalable model of an isolated off-world community, and the primary goal for SIMOC is to provide a mathematical simulation for an off-world colony. And right now it uses agent modeling, and the sponsor would also like to have machine learning available in the future iterations of the project. But for now, the focus of the capstone team was just using agent modeling, which is basically a simulation that focuses on the interactions and behaviors of agents and between agents. And in our case, the agents are humans, plants, structures, and the environment. Originally, the sponsor had wanted a game-like interface to allow for a more interactive user experience. But later, the sponsor shifted focus to be more on the scientific value of the simulation. So the team dropped a lot of the game-like qualities in the interface and decided to use a web application to allow a user to control the initial parameters of the simulation and be able to have data printouts. The sponsor also introduced an idea for a baseline mode for the simulation, which basically involves taking real-world habitat simulations and trying to match the data that we collect and see how closely it reflects the real-world experiments. Overall, the sponsor wants the capstone team to be focused on creating a detailed and accurate model for an off-world human colony that allows for the user to generate and collect data and have the ability to replicate an experiment and modify the initial parameters while providing a structural foundation to allow for future iterations of SIMOC to have greater functionality.
Hi, my name is Greg Schoberth, and I will be discussing the design and architecture for Team 15's project, the SIMOC Mars Colony. So, since the last time we did our presentation, a number of things have changed in our design and a bit of, not really in our architecture, with guidance from our sponsor to better fit his needs. So, previously, we were making more of a game UI similar to that of SimCity. Now the direction has changed to be more of a scientific dashboard, as will be seen later in the presentation. This is more in line with the end goals of our sponsor to provide a means for the science community to run simulations for uh, a Mars colony. The architecture that changed with that, it remained the same as was when we were using Unity. The overall design changed though. Instead of using the Unity client for the client side, we actually switched to a web app using HTML, JavaScript, CSS, all that stuff to make it look nice. And we actually are using Flask to run our front end, which is also uh, part of our backend. So we are using Python Flask for that. Uh, Now we are utilizing Flask's templating system to better design a single page application. And we have come very rapidly from where we were previously using Unity to where we are now using a web app.
This is Terry Turner with Team 15. I will be going over the risk mitigation and management portion of the design review. I created a impact chart based off of the likelihood that a risk will happen, going from very low to high, and I color coded it and ranked them from low to medium to high based on how they would affect our project. First off, one of the risks that we run into is the external project dependencies, basically stuff that we can't control, like deadlines, requirements, and scope. Usually, we handle that with proper Scrum procedures, multiple branching for all our tasks, and Git and proper program modularization. The infrastructure, basically proper use of third-party software like Git, Slack, emails for communication. Basically, we have backups of everything locally stored, and if one communication channel goes down, we usually contact each other with email. So we usually have backups. Poor group dynamics right now, that isn't a problem. We usually handle that with proper tracking, planning, and work distribution through Tiger.io. Sponsor communication right now is really good. That is really low on the risk impact chart. We have weekly meetings, sometimes multiple, to flesh out everything with the sponsor. And design limitations, basically stuff that we didn't flesh out initially with the sponsor. But right now, everything seems to be going fine. That doesn't seem like it's a problem. And that's it for the risk mitigation part.
Hi, my name is Ben, and I'm going to be discussing the insights that we had for our project. For process analysis, we did tend to have user stories left unfinished sometimes at the end of sprints. We have gotten a little better at this as we've gotten more familiar with what everyone's capable of and what they can finish in the time frame for the sprint. Stand-up meetings tend to be informal, short and to the point. We try to just discuss what we have done and what needs to be done to get the sprint completed. For the project, Agile has been pretty useful for handling the changes that we've had come in from the sponsor, and we were able to just add new user stories to the backlog and remove them as we need to, and scrap what no longer is needed. Things that could have been done better. I think we just spent more time fleshing out the design and requirements. I think we've had some issues with the current design as it stands. Definitely could have been done better given more time to work on this. This was prevented a little bit due to an initial lack of communication between the sponsor at the start of the project, and as well the time constraints imposed by the course. I think we've also spent more time researching frameworks and design patterns to help the overall implementation and make everything go smoother and just easier to code against. I think we'd also like to spend more time enforcing code quality and doing reviews, making sure everyone's using best practices. But again, this has been prevented somewhat due to time constraints and then also due to unfamiliarity with some of the languages we're using.